EaseVoice Trainer is an open-source voice cloning trainer developed by MegaEase. It's built on the models and concepts from the GPT-SoVITS project. To make it simple, stable, and user-friendly, MegaEase rewrote the entire front-end and part of the back-end training and inference code. This lowers the barrier for voice fine-tuning with GPT-SoVITS, so users can easily and efficiently clone voices with just a few steps. All the code is open-sourced on Github. Feel free to visit our project page, give it a star, submit issues, or even contribute to the development. EaseVoice Trainer features a clean, intuitive interface with a smooth user experience. It supports one-click voice cloning and effortless speech synthesis. One-click fine-tuning is also available, perfect for beginners. With simple project and folder management, you won't get lost in a sea of audio files. And for advanced users, TensorBoard is built in to help monitor training metrics. Now, let's walk through how to use EaseVoice Trainer. First, choose the default root directory. All project files will be stored in this folder. Next, select the default project. Enter the EaseVoice Trainer interface. On the left, you'll find the menu bar for switching between different modules. In the lower left corner, you can easily add, switch, or delete projects. All cloned and trained models are saved inside the current project. Each project is stored as a folder under the root directory. On the right, you'll see File Management and System Monitoring. The File Manager shows detailed contents of the current project folder, like audio files and models, so you can keep track easily. And in the center is where the core features live. Let's start with the voice cloning feature. Just upload a voice sample, type in the text you want to synthesize, and the system will capture the tone, pitch, and rhythm of the original voice. Then clone it into a natural, fluent new voice. Let's try recording a sample voice. Read a short line, 3 to 10 seconds. Then enter the text. We'll use the default model and settings. Click Start Synthesizing to begin. Now compare the original with the cloned voice.
夜晚的虫鸣声此起彼伏，偶尔传来狗吠声，远处的汽车轰鸣渐渐消失。我是测试员，很高兴认识你。
The similarity is already quite good. Click Download to save the audio locally. Now let's try uploading an existing audio clip. Here I have a 5-second recording of Squidward's voice. Enter some text and click Start Synthesizing. Comparing the original and the cloned version.
我希望我的眼前少一点黄色，希望你能明白。我是测试员，很高兴认识你。
You can hear that the tone in the cloned voice sounds a bit off. To get different voice styles, you can tweak settings like speed and temperature. Let's make a few adjustments. Set top_P to 0.9 and temperature to 0.5. Click Start Synthesizing again. Now listen.
我是测试员，很高兴认识你。我是测试员，很高兴认识你。
The voice tone shifts from lively to more calm. You can refer to our voice cloning parameter guide for recommended settings. Still, no matter how we tweak the settings, the cloned voice doesn't really match Squidward's original tone. That's because we're using the default GPT-SoVITS model. To achieve higher similarity, you can fine-tune both the SoVITS and GPT models. Voice cloning uses just a few seconds of audio. But fine-tuning needs several minutes of high-quality target voice data. By training 2 new models using this longer audio, you can significantly boost the cloning accuracy. Let's switch to the model training page. There are 2 training modes, Basic and Advanced. In Basic mode, training is one-click simple. Just upload the target voice audio to the specified folder. Then click Start Training. The trained model can be used right here. Advanced mode gives you full control, with more detailed steps and parameter settings for deeper customization. It's divided into two parts: data pre-processing and model training. Let's start with the data pre-processing part. We begin with voice separation, used to isolate vocals from background audio. You don't need to change the input-output paths. Just pick the right separation model. For songs, we recommend using HP5. For voices from films or anime, choose HP2 or HP3. For self-recorded audio, go with VR. Since my file is from anime, I'll select HP2. Click Start Separation. Once it's done, go to the Output folder in File Manager. You'll see two new folders, Vocals and Accompaniment. We'll keep the vocals for further processing. Delete the Instrumental folder. Next, split the audio into smaller segments. Default settings are fine for most cases. For better performance, set the number of threads to about 50 to 75% of your CPU cores. Click Start Audio Splitting. After success, continue with voice denoising. Now convert audio to text using ASR. The system automatically transcribes your audio, supporting both Chinese and English. After that, you'll move on to text verification. Perform a further check to ensure the AI-generated text is accurate. We provide an audio-text alignment table. Review and correct any transcription errors, punctuation, or phrasing. Then, just click Save. Once proofreading is done, click Finish Labeling. Now we move on to model training. Click Start Normalization first. Once it's complete, a file will be generated. That's the one used for the final training step. Start with training the SoVITS model. The batch size determines how much data is fed into the model per step. Choosing the right size improves training efficiency. You can refer to this chart to match batch size with your GPU memory. The total training steps and learning rate depend on your audio quality and duration. It's fine to start with the default values. If the results aren't ideal, try lowering the learning rate and increasing training steps. For example, since my audio is only 2.5 minutes long, I increased the training steps to 24 and lowered the learning rate to 0.3. Tick both checkboxes, then click Start Training. Once the SoVITS model is trained, proceed with GPT model training. Don't set the GPT training steps above 20. Sticking with the default is usually best. Click Start Training. After both models are trained, you can find them in the File Manager on the right. You can rename your model files if you like. Otherwise, they'll be saved with a timestamp-based name. Let's go back to the voice cloning page and test our new model. Use the same input audio and text as before. Then, switch the model. Adjust the parameter. Click Start Synthesis. Once it's done, let's take a listen.
我是测试员，很高兴认识你。
Compared with the default model.
我是测试员，很高兴认识你。我是测试员，很高兴认识你。我是测试员，很高兴认识你。
You can clearly hear the improvement in voice quality. That's the benefit of model training. We also offer a console feature. You can monitor model training metrics through TensorBoard. These graphs help you understand whether the training process is stable and whether your model is actually learning the sound features effectively. Finally, thank you for watching. We invite you to try out EaseVoice Trainer, our open source project by MegaEase. See you next time.